Okay, so the derivative, it's the equation of the line that touches the function at a particular point. So for problem number one, what you need to do for the derivative is you first need to write it as a polynomial function. Okay, so here it's f of x equals -4. What I'm going to do, I'm going to go ahead and rewrite it as a polynomial function with an x. So that's going to be -4 times x, x to the what power? Since there's no value, there's no x, I'm going to have that x to the 0 power. So the derivative, what you do in this process is you multiply the exponent times the constant number, and then you decrease the number by 1. Okay? So when you multiply 0 times -4, that would be 0. So the way you're going to write it is like this. F prime of x, that is the derivative notation, equals -4 times 0 is 0, x, and then 0 minus 1 is -1. But see, 0 times x to the -1, it's 0. So therefore, the derivative is just 0. Okay, so all you need to do is get the exponent multiplied by the constant and then decrease the exponent by 1. That's all that is, okay? Now the second problem, number 2. See, this is already in polynomial function. So what we do, we multiply the 3 times the 2. So this is going to be f prime of x, the derivative of the function, is 3 times 2 is 6x, and then we're going to go ahead and decrease the exponent by 1. So 2 minus 1. It's just 1, right? Okay, so either you put it or you don't have to put it, if it's a 1. Now the second one. The x on the -4 has a 1. So when you multiply 1 times -4, that is -4. And then 1 minus 1, that is 0. So I don't have any x anymore. So this is a function right here. That is a derivative function. One more time. What you do is you multiply. See, the x doesn't have anything here. I put a 1 because it's understood that there's a 1. So that 1, you multiply it by the, God bless you, by the constant, the coefficient. So it's 1 times -4 is -4. And then you decrease the exponent by 1, so it's -1. So 1 minus 1 is 0. So it's x to the 0 power or just no x. That's it. Next, number 3. This is like having a 1 in front of the x right here. So when you get the derivative, and over here, the constant function is like having x to the 0 power. So when you get the derivative, you multiply the exponent times the coefficient. So let me write the notation. F prime of x, the derivative of the function, is 2 times 1 is 2. And then is 2 minus 1, because you always decrease it by 1. 2 minus 1 is just 1, right? We don't have to put it because the 1, you don't have to put it. And then x to the first power, and then is 1 times 7 is 7. And then is 1 minus 1, that is 0, so I don't have that anymore. And then what's going to happen when I multiply the -2 times the 0? It's just 0, so I don't have to put that in. So here, that's going to be the derivative right there. Okay. Go ahead and try number 4. Give me the derivative for number 4. So number 4, the derivative is f prime of x, derivative of the function, it is right, is 3x squared plus 5. Because it's 1 minus 1 is 0, so you don't put that in. 3 minus 1 is 2. Now, how about number 5? Do any of you have number 5? What is the answer to number 5? Now, the key is to keep this problem as a kind of like a polynomial, where you have x next to the number. And notice that the x is underneath. So I need to bring it up and put it right next to the number. When you bring the x to the top, do you remember the rules on in geometry on exponents. If the x moves direction, you change the sign of the exponent. So if it was a positive 1 at the bottom, when you bring it up, becomes negative 1. So when you change the position of the variables, the exponent changes the sign. Now you can go ahead and work out this problem, and this is going to be f prime of x equals, and then you multiply negative 1 times negative 2, it's positive 2. And then is x, and then you subtract 1 from that negative 1, and that becomes negative 2. So after you do that, you need to make it a positive exponent, bring it down. So it's f prime of x equals negative 2 times 2 is, oh, I'm sorry, I'm getting the second derivative, not that. Do you notice what I was going to do? I was going to multiply negative 2 times 2 again. That is called second derivative. Okay, and the second derivative is for something else. It's not to get the tangent line. It's for something else. So we're just going to do the first derivative. So anyways, the equation should be a 2 over, and then bring the x to the negative 2 to the bottom to make that exponent positive. And that's the answer. Yes, sir. Okay, so now for problem number 6, first of all, I need to rewrite that, not with radicals. I need to have exponents. So the way you rewrite it is going to be f of x, God bless you, equals x minus 3, and that square root of is like having a 2 as a root, and it's like having this binomial raised to the first power. So what happens with radicals when you rewrite it from radical form to exponential form? Remember that you bring this to the bottom. It becomes 1/2. So that's the way you need to rewrite it. So it's going to be x minus 3 raised to the 1/2. And that 1/2 is just representing the radical that you have on the problem. Now once you write it like that, then get the derivative of that. So the derivative, again, what you're going to do with problems like this when you have a binomial is you bring the number that is in the front, which is like a 1, you multiply 1/2 times 1, and that would be 1/2. So the derivative of that is f prime of x equals 1/2 times 1 is 1/2. You're going to keep the binomial, and then you're going to subtract 1. But subtracting 1 in terms of 2's is going to be 2 over 2. So that 1 is just 2 over 2. So 1/2 minus 2 over 2 is just what? 1. Negative 1/2. Like that. And now that's a negative exponent, so we need to make it a positive exponent. And the way you make it a positive exponent is like this. See, that is like being on the top. So now I'm going to bring that to the bottom. So I'm going to put 1 over, and then I'm going to have, that's going to be positive. See, I have the 2 in the bottom. X minus 3 to the positive 1/2. And let's make that 1/2 into the way that it was as a radical. So the final step here would be 1 over 2. When you bring this as a radical, again, it becomes the square root of x minus 3. And that is the derivative of that function. Okay? So in the event that you have variables on the bottom, just bring them to the top, change the sign, and then make sure that you have those exponents, positive exponents. Okay? And the same thing with the radicals. Bring it up, change it into from radical to exponential, get the derivative, subtract the 1, and then make sure you have that again back into a radical form. Okay? Now, the next set of problems.
So that's the answer?
That's the answer. That is the answer. Now, for number 7, it says, find the derivative of the function at the specified point. So, first of all, we need to get the derivative of the function. Once we get the derivative of the function, then we're going to say, what's the derivative of the function when x equals to 2? And then we work it out, and that would be the answer. Okay, so let's get the derivative of number 7. Wow, there were several. Okay, so number 7, first let me get the derivative. So it's f prime of x equals, this is like x to the first power, x to the 0 power. So when you multiply the exponents, that's going to be 1 times 5, and that would be 5. And then x, when you subtract a 1 from that exponent, becomes a 0. So that would be x to the 0 power, right? And then for the second one, it's going to be plus 0 times 9 is 0, x, and then this is 0 minus 1, so it's going to be minus 1. Now when you rewrite that, all that is going to be f prime of x equals 5. And that's a derivative. Why is that? Because x to the 0 power is like not having a variable, right? And 0 times a variable is equal to 0. So this is the f prime of x. Okay, so this is a derivative. Now once you do that, you're going to have to get the derivative, which is f prime of 2. What is that equals to? Well, there's no x here where I can put the 2 into. So therefore, f prime of 2 is just equals to 5, because there's no x that I can plug it into and then simplify it. So that would be it.
But if there was an x, you just have to do like if they go like 5x, then it's like x
Plug it
is
in.
equal to 2, so it's 5 equals 2.
That is right. If it's like at 5x, that's right. You just put the 2 into the x, and then you multiply 5 times 2, and then the answer would be 10. Yes, good point. Thank you, Valerie. Okay, now for problem number 8. Let's get first to the derivative of the function f prime of x. Okay, so what's the derivative when you multiply?
2 times 2.
Negative 2 times 2, which is negative 4, x to the what power?
So the first one.
To the first power, or I just don't put anything. And what about the second term? That would be what? 1 times.
0x minus 2 to the power of -1.
Okay, so this is like a 1 right here, right?
So
Plus 8, so it's 1 times 8 is 8, and then it's x to the what power? 0, so I don't have to put it there, right? It's just 8. So that's the derivative. Now let me find the derivative at x is equal to 7. Instead of x, I'm going to put 7. So it's negative 4 times 7 plus 8. So negative 4 times 7 is negative 28 plus 8, which is negative 20. And that's the answer. Okay.
Yeah, and f prime with 7 equals to 20.
That is right.
Circle 20.
That is right. See, I have the notation here, so I'm already giving that at the beginning. So f prime of 7, and then this is, all of this is my work, and then this is the final answer. Okay, so I'm already giving that notation here, and that is very important, Adrian. Yes, thank you. Now go ahead and try number 9. Give me the derivative of the function at x is equal to 0. Okay. Thank you. I couldn't find it. Thank you. Okay, so did you get 7? Yes, wonderful, yes. Number 10, you first need to get the, let me change the, let me see if this is good. Okay, so for number 8, it's 3 times 1 is 3, subtract 1 is 2. 1 plus 5 is 5, 1 minus 1 is 0, so no x over here. So when I let the x be equal to 1, 1 square is just 1 times 3 is 3. And then plus 5, add them up, and that is 8. Now, for number 11, you first need to rewrite the function as exponential form, okay, where you have the x to an exponent. So that x has a 1, when you move it up, becomes a negative 1. Then you get the derivative of this one. So it's negative 1 times 8 is negative 8. Negative 1 minus 1 is negative 2. Then you rewrite it to make it a positive, bring it down, and that becomes positive. Then once you have it like that, then you find the derivative at x equals negative 1. So at x negative 1 square, that would be positive 1, negative 8 divided by 1, and that is negative 8.
Or you get a negative 8x, like the negative 8.
This one? Okay, this one, because when I multiply the negative 1, say this one here, this negative 1, because that one, it was a positive 1, you bring it up and becomes negative 1, right? So negative 1 times 8 is negative 8. And then
okay, and then the negative 1 minus 1.
minus 1. So negative 1 and negative 1 becomes negative 2. Yes. Now, well, let's go ahead and try number 12. Number 12. Here, you rewrite it first. So it's going to be f prime. Let me do it without the prime notation first. First, let me just rewrite it. So f of x equals negative 10 x to the negative 1. Now, the derivative function should be, what should be the derivative function? Anybody can give me that? Positive 10 x to the what power? Negative 2. Beautiful. So that's the derivative function. Now let's get the derivative function at x equals 12. So f prime of 12 is 10. Okay, and now I'm going to have to bring this to the bottom, right? So I'm going to bring it over here in the bottom. So I'm going to have 12 raised to the second power. Let me rewrite that because that's not a positive exponent. So the positive exponent, f prime of x, that should be 10 over x squared, right? Before I plug it in. So that is the derivative function, and then I plug in the 12 into the x. Now you simplify that, and when you simplify that, that's going to be 10 divided by 144. Right? And the only thing you can do at that point is just to reduce it. By 2 would be 5. By 2 would be 72. And that's about the only thing that you can do. You cannot reduce it anymore. So that is f prime of 12, 5 over 72. Questions about this? So far so good? Okay, so now number 13. Okay, number 13, first of all, I need to bring it up. So f of x is 8 parentheses x plus 2 raised to the negative 1. Now my derivative function f prime of x equals to what? Negative 8 parentheses x plus 2 raised to what power? To the negative 2. Then I rewrite it first. F prime of x equals negative 8, and then I bring that to the bottom. X plus 2 raised to the second power. That is my derivative function. Now I need to find the derivative at point x equals to 0. So f prime of 0 is negative 8 parentheses 0 plus 2 quantity square, which is negative 8 over 2 square, and that is 4, isn't it? So the answer here is negative 2. So what you're getting with this is every time you get the derivative at a point given, you're finding the tangent line that touches that graph, that function at that point. That's what that is. Okay? Any questions about this, guys? No? Okay, so if you get to finish on the notes, any 5 problems, I'll go ahead and stamp it, and then I'll pick it up on Monday, and on Monday I'll close up the grade book with those 2 assignments. The notes and the assignment will be turned in together. So on the assignment, if you finish up 5 of the problems, I'll stamp it and you get the 10 extra points. Okay? Any questions? No? Okay, so